The path of a projectile is given by the rectangular equation y is equal to 7 plus x minus 2/100 x squared. Part A. Find h, v sub 0, and theta for the set of parametric equations x is equal to v sub 0 cosine of theta times t and y is equal to h plus v sub 0 sine of theta times t minus 16t squared that model the path. Part B. Use a graphing utility to graph the rectangular equation for the path of the projectile. Confirm your answer in Part A by sketching the curve represented by the parametric equations. Part C. Use the graphing utility to approximate the maximum height of the projectile and its range. Part A. Write the parametric equations and the rectangular equation. Note that the expression h plus v sub 0 sine of theta times t minus 16t squared and the expression 7 plus x minus 2/100 x squared are each equal to 0, which means you can set the expressions equal to each other. Next, substitute v sub 0 cosine of theta for x. Simplify. The resulting equation is h plus v sub 0 sine of theta times t minus 16t squared is equal to 7 plus v sub 0 cosine of theta times t minus 2/100 v sub 0 squared cosine squared of theta times t squared. You can use the resulting equation to find the values of h, v sub 0, and theta. First, equate the constant terms. You will get h is equal to 7. Next, equate the coefficients of t. V sub 0 sine of theta is equal to v sub 0 cosine of theta. Divide each side of the equation by v sub 0. You will get sine of theta is equal to cosine of theta. Divide each side of the equation by cosine of theta. Sine of theta divided by cosine of theta is equal to 1. Rewrite the left side of the equation as tangent of theta. Tangent of theta is equal to 1. Tangent of theta is equal to 1 when theta is equal to 45 degrees. Lastly, equate the coefficients of t squared. Negative 16 is equal to negative 2/100 v sub 0 squared cosine squared of theta. Divide each side of the equation by negative 2/100. The result is 800 is equal to v sub 0 squared cosine squared of theta. Next, substitute 45 degrees for theta. Evaluate cosine of 45 degrees. 800 is equal to v sub 0 squared times the square root of 2 divided by 2 squared. Simplify to get 800 is equal to v sub 0 squared times 2/4. Multiply each side of the equation by 4/2. Simplify to get 1600 is equal to v sub 0 squared. Take a positive square root of each side, so v sub 0 is equal to 40. Use the values of h, theta, and v sub 0 to write the parametric equations. X is equal to 40 times cosine of 45 degrees t. Y is equal to 7 plus 40 sine of 45 degrees t minus 16t squared. Also recall the rectangular equation. Y is equal to 7 plus x minus 2/100 x squared. Part B. Use a graphing utility to graph the rectangular equation. y is equal to 7 plus x minus 2/100 x squared. Sketch the curve represented by the parametric equations x is equal to 40 cosine of 45 degrees times t, and y is equal to 7 plus 40 sine of 45 degrees times t minus 16t squared. Construct a table of values. When t is equal to 0, x is equal to 40 times cosine of 45 degrees times 0, which is equal to 0. And y is equal to 7 plus 40 times sine of 45 degrees times 0 minus 16 times 0 squared, which is equal to 7. Perform similar calculations for different values of t. Plot the points x, y from the table. Draw a smooth curve through the points. Note that the curves are the same, so the answer in Part A is confirmed. Part C. Use the graphing utility to approximate the maximum height of the projectile and its range. The maximum height is 19 5/10 feet. The range is approximately 56 2/10 feet.